Hello everyone, welcome back to the channel. In today's video, we're going to be talking about the so-called hot topic about GPTs or transformers, or you might have heard the terms like ChatGPT, Bard, Llama, and so on and so forth, which help you in your day-to-day activities such as code generation, document completion, document generation, summarizing text, getting hidden meanings from text, or answering your question and answer formats from large documents. But basically, to many people, this seems like magic. So let's try to understand what are these GPT or generative pre-trained transformers, or how do they exactly work. So basically, these are nothing but large language models. And in today's video, we are going to take a look at how these large language models are built in an easy manner so that anyone can understand that, because before using this new and fascinating technology, it's important to have a conceptual understanding on what we are using. So let's take a look at this. I'm going to try to simplify this as much as possible. So what is a large language model? A large language model, in a nutshell, consists of two simple things. One is the code file, that is basically the neural network architecture, that is the core of the large language model, and you have the parameters file, which are nothing but the weights or the parameters. We often hear, when we talk about models, we often hear that this is a 70 billion parameter model or a 130 billion parameter model. So these are the weights of the parameters. Basically, when you train a neural network, you get something called as weights, which are the learnings of the neural network. And these learnings are stored in the form of parameters. There is a simple depiction of a large language model. The neural network architecture can be implemented in a simple C file or a Python file, and they are available to download for any open source models. You will not get them for any closed source models, but for open source models like Llama, Llama 2, you will get them. And the parameters weights also can be downloaded. How these parameters work among each other is something that is not known today, but we have to just take it as a fact that they work in a manner to generate the documents in a meaningful fashion. So let us see how these large language models are built. The building process of a large language model consists of three fundamental processes. One is pre-training, the next is supervised fine-tuning, and the third process is RLHF, that is reinforcement learning from human feedback. So let's take a look at these three processes in detail. In the pre-training process, a large corpus of document. This typically involves the crawling data of the internet, or the large corpus of data from the internet, say tens of terabytes of data, and this corpus of data is fed into the neural network. Okay, and basically this training is a very long process. It's a very resource consuming process. It can take around 6,000 GPUs, and it can cost up from around $2 million. And this process is done, and this process helps us generate our base model. So what this process does is the large corpus is fed into the model, okay, and the model is then trained on this large corpus, and then the model starts dreaming text. So basically what the model does is it is very simple. It's the neural network is fed a sequence of words, and it is trained to predict what is the next word in the sequence. And whatever is the next word it is joined to the original sentence, and it is again fed back into the neural network. You can think of this something as an auto regression. And this is how the process works in a very, very simple manner. So when we give a large corpus of text and we train the model, when we feed it then some text, the neural network then starts to dream text. What we mean about this, that suppose we give the pre-trained network some text, like say we give it a small essay that I am a scientist, I work on data, I do data analysis. The neural network will then predict what are the next best sequence of words to complete the text. Some of it will be factually true, some of it will be hallucinations. This is basically based on its past knowledge. So this is called the pre-trained or the base model. Whatever are the learning or the model are called as weight or parameters. Okay. Now the next process we do is something called as supervised fine-tuning. In this process, we take a smaller corpus of documents, and this document we want the model now to make use of its knowledge and to align it with human responses in the terms of what responses human expect. So we feed it question and answer documents, right? So I'll ask it, we'll ask people to write questions and also ask experts to give the answers for those questions. What are the accurate and correct answers? And these corpus of question and answers are then fed into the model for supervised fine tuning. So this supervised fine tuning, why it is called that way? Because the model is now given a supervised machine learning technique where it knows what is the question and what is the answers. And from that, it derives on the knowledge on how it is supposed to use its knowledge learned in the pre-training process to answer and give response that are more aligned to human responses. Okay. So it will give a more aligned response in this case. And finally, what happens is, again, these weights and parameters, which are updated, then they are used for another process called reinforcement learning from human feedback. Here, we ask the model some questions, and now the model knows how to answer. Even it is trained on question and answer. So even if you ask it to write a code for you or to write a document for you, it knows what kind of response it's supposed to give. Even if that question and answer might have not been there as the original training set, because this is a very small corpus here, 100,000 documents, it still has understood how it should respond and how it should give you factual data to the most extent. There will obviously still be some hallucinations, but it will give you factual data because it is giving you aligned response now. And then in this reinforcement learning from human feedback, what happens is when we ask it questions, it will give us multiple answers, and in this process we can do comparative analysis. Say instead of having to write multiple answers, if we ask it to give us multiple answers and then we choose which answer is correct, right, or the most desirable answers, then from this feedback the model is learning on how it should respond accurately so that humans can use this response, or it is more aligned towards human behavior and responses. So that is more useful to humans. Okay, this is more accurate also and lesser prone to hallucinations, and it has better guardrails. And finally, from this we generate something that is called as the model with the final parameters as well as the neural network architecture, which can be downloaded and used, or in case of closed LLMs, they can be consumed as types of services. If you get a model with say 70 billion parameters, then the size of this parameter file is around will be double that, because each parameter is 2 bytes, so it will be around 140 GB. So you can download that and then you can play along with it and also tune it further for your needs. So I hope you have understood large language models in a very simplistic manner. Hope this is useful for you. If you want me to make a detailed video on any other specific topic or of our transform works, do let me know. Feel free to leave a like and a comment on this video, and do not forget to subscribe to my channel for the latest on machine learning in Python, Pandas and in Excel. Thank you.